The universe is a big place, really big, and it's filled with wonders that stretch our imagination to its very limits, sometimes even beyond. We often dream of finding other Earths, planets like our own, peaceful and inviting. But the cosmos is also home to worlds that are far from tranquil, places that would be nightmares if we ever tried to visit them. Today, we journey to one such world, a planet that redefines extreme. Its name is HD 189733b. It's a place where beauty hides a terrifying reality, a true monster in the cosmic zoo of exoplanets. Imagine a sky not of gentle water rain, but of molten glass. Yes, you heard that right, liquid glass falling sideways. This isn't some science fiction writer's overactive imagination. This is a real phenomenon on HD 189733b, a world where the weather report would always be deadly. The temperatures are so incredibly high that rock-forming minerals, silicates, vaporize in the atmosphere. These silicates then condense into tiny droplets of glass, forming clouds unlike anything we see on Earth. It's a truly alien weather system, a constant storm of shimmering, deadly shards. And if the glass rain wasn't enough to deter you, consider the winds. These are not your average earthly breezes, not even hurricane-force gales. So where is this extraordinary yet terrifying planet located in the grand cosmic theatre? HD 189733b orbits a star named HD 189733a. You can find this star system in the constellation Vulpecula, the Little Fox. It's a faint constellation, perhaps not as famous as Orion or Ursa Major, but it holds this remarkable gem. The system is about 64.5 light-years away from our own solar system. Now, that might sound incredibly far, and in human terms it certainly is. But in cosmic terms, it's practically in our backyard, making it one of the closest exoplanets of its type to Earth. This relative proximity is a boon for astronomers because it means the star and its planet appear brighter, making them easier to study in detail with our telescopes. The star HD 189733a is an orange dwarf, a bit smaller and cooler than our Sun. Interestingly, this star is not alone. It has a companion, a faint red dwarf star called HD 189733b, making it a binary star system. The two stars orbit each other at a considerable distance, much farther than HD 189733b orbits its primary star. This cosmic dance adds another layer of complexity and interest to this already fascinating planetary system. HD 189733b belongs to a category of exoplanets known as hot Jupiters. This name gives you a pretty good idea of what they are like. They are gas giants, similar in nature to Jupiter, the largest planet in our solar system. They are primarily composed of hydrogen and helium, lacking a solid surface like Earth or Mars. Think of them as enormous balls of gas, swirling with complex atmospheric dynamics. But there's a crucial difference that earns them the hot part of their name, setting them apart from our own familiar gas giants. These planets orbit incredibly close to their parent stars. Much, much closer than Jupiter orbits our Sun. HD 189733b, for example, orbits its star at a distance of only about 3 million miles, or roughly 4.8 million kilometers. This is about 1/30th of the distance between Earth and our Sun. As a result of this extreme proximity, these planets are searingly hot. The side of HD 189733b, facing its star, can reach temperatures well over 1,000 degrees Celsius, or about 1,800 degrees Fahrenheit. One of the most significant features shaping the extreme environment of HD 189733b is something called tidal locking. This phenomenon occurs when a celestial body orbits another. and the gravitational forces cause one side of the orbiting body to permanently face the primary. Our own moon is tidally locked to Earth. That's why we always see the same face of the moon. For HD 189733b, being so massive and so incredibly close to its star, tidal locking was an inevitable outcome of its gravitational dance. This locking has profound consequences for the planet's climate. Imagine one side of the planet, the day side, perpetually bathed in the intense radiation of its nearby star. This side is constantly superheated, experiencing temperatures that soar above 1,000 degrees Celsius, around 1,832 degrees Fahrenheit. There is no night on this side, no respite from the relentless stellar furnace. It's a permanent scorching day. Section 5, Weather Gone Wild, Rains of Molten Glass. Let's delve deeper into that truly bizarre weather forecast for HD 189733b, Sideways Rain of Molten Glass. The extreme temperatures on the day side, consistently over 1,000 degrees Celsius, are key to this phenomenon. At such temperatures, many materials we think of as solid, like rocks, can actually vaporize. The atmosphere of HD 189733b is thought to contain silicate particles, the very stuff that makes up sand and glass on Earth. On the scorching day side, these silicates are heated so intensely that they turn into a vapor, mingling with the other atmospheric gases. These silicate vapors don't just stay put on the day side. They are swept up by those incredibly powerful winds, which blow from the superheated day side towards the relatively cooler night side. As this silicate-laden air travels, it begins to cool down, though cool is a very relative term here. When the temperature drops sufficiently, even if it's still hundreds of degrees Celsius, these silicate vapors can condense. Just like water vapor on Earth condenses to form clouds and rain, the silicate vapor on HD 189733b condenses to form tiny droplets of liquid glass. So you get clouds made of glass particles. And from these clouds, it rains. Section 6. A beautiful deception, the azure blue killer. When we look at images or artists' impressions of HD 189733b, one of the first things that strikes us is its colour. It's a beautiful deep azure blue. It's a hue reminiscent of our own Earth when seen from space, or perhaps the distant ice giant Neptune. This vibrant blue colour might at first glance suggest a world with vast oceans of liquid water, a welcoming blue marble in the cosmos. However, as we've learned, this couldn't be further from the truth. The blue colour of HD 189733b is a beautiful deception, masking a truly hellish reality. So if there are no oceans, why is it blue? The answer lies in its atmosphere, specifically those silicate particles we just discussed, the very same ones responsible for the glass rain. Scientists believe that these tiny particles of condensed glass, or perhaps the silicate haze high in its atmosphere, scatter blue light more effectively than red light. This is a process somewhat similar to what happens in Earth's atmosphere, known as Rayleigh scattering, which is why our sky appears blue. Section 7. A window to alien skies. Studying exoplanet atmospheres. HD 189733b isn't just a cosmic horror show, it's also an incredibly valuable asset for scientific research, particularly in the field of exoplanet atmospheres. Its relative proximity to Earth and the fact that it transits a bright star make it one of the most studied exoplanets to date. Each time it passes in front of its star, a tiny fraction of the starlight filters through the planet's atmosphere before reaching our telescopes. This is a golden opportunity for astronomers to learn what that atmosphere is made of. The primary technique used is called transmission spectroscopy. As the starlight grazes the edge of the planet and passes through its upper atmosphere, different atoms and molecules in that atmosphere absorb specific wavelengths or colors of light. It's like shining a light through a colored filter. Some colors pass through, while others are blocked or dimmed. By analyzing the starlight before, during, and after a transit, scientists can identify these missing wavelengths and thus deduce the chemical makeup of the planet's atmosphere. Section 8. Lessons from a Tormented World. Understanding Extreme Planets. HD 189733b serves as an extraordinary natural laboratory, a place where we can observe planetary processes occurring under conditions far more extreme than anything found in our own solar system. This tormented world, with its searing temperatures and ferocious winds, pushes our theories of planetary science to their limits. By studying it, we gain invaluable insights into how planets behave when subjected to intense stellar radiation and strong gravitational forces. It's like stress testing our understanding of planetary physics and chemistry on a grand cosmic scale. One of the key areas where HD 189733b provides crucial data is in atmospheric dynamics. The massive temperature difference between its day side and night side, driven by tidal locking, creates some of the most extreme wind speeds ever recorded on any planet. Scientists can use observations of these winds and the way heat is transported around the planet to test and improve their computer models of atmospheric circulation. These models are not just for understanding alien worlds, they also help us better understand atmospheric processes on Earth, albeit under much milder conditions. Section 9. The Universe's Endless Surprises, what HD 189733b teaches us. The study of HD 189733b is a profound reminder of the sheer, almost bewildering, diversity of planets that populate our universe. For a long time, our understanding of planets was limited to the 8 or 9, depending on when you grew up, in our own solar system. But the discovery of thousands of exoplanets has blown that limited view wide open. We now know that worlds come in all shapes, sizes, temperatures, and compositions, many of them far stranger than we could have ever imagined. HD 189733b, with its glass rain and supersonic winds, is a poster child for this cosmic variety. This bizarre blue planet fundamentally challenges our Earth-centric notions of what a planet should be like. It forces us to expand our definitions and our understanding of planetary science. It shows us that the laws of physics and chemistry can lead to outcomes that are utterly alien to our everyday experience. There are no Earth-like oceans on HD 189733b, no gentle breezes, no life as we know it.